All right, so this is worksheet 8-4. Worksheet 8-4. Obviously number 10. What do you want to do first on number 10? I.e., why did I pick this problem to do? I need to simplify I need to add those fractions. And in order to add fractions, I need a common denominator. Some of you are going to get a common denominator by multiplying this one by x minus 3 and this one by x squared minus 9. That would work, but it's really the long way around. Let's factor this guy first. That will make life much easier. Because now all that's needed to get a common denominator is an x plus 3 on that first fraction. Oh, did I? No wonder you're looking at me crazy. There we go. So now I've got a common denominator of x plus 3, x minus 3. And in the numerator, let's see, 2x plus 6 minus 4 is 2x plus 2. Which, I'm out of space, I guess I could factor out a 2, and that would leave x plus 1. But since it doesn't factor, since it doesn't cancel, I don't really need to do that. Now, if it would cancel, I would definitely need to do that so I could see the whole and go from there, but it doesn't cancel, so I'll leave it like that. Okay, obviously it's super important to get that step right, because if you mess up that step, there's no way you're going to get any of the rest of this correct. So please be careful when adding and subtracting fractions, because if you can't do that, then the rest of this problem is going to be kind of shot. And I will try to be generous and lenient and merciful and gracious toward you with grading, but there's only so much I can do. If you can't add, then you're going to miss all these, and I'll try to give partial credit when I can easily spot what's happened, but it'd just be better if you could factor correct and get a common denominator and add. Okay, let's start picking on people. Let's see. Ella, what about the domain? All right, why can't x be 3 and negative 3? Yep. And what's wrong with factors in the bottom being 0? Good. Can't divide by 0, so that would make it undefined. So we can't use plus or minus 3. Christian, I'm jumping around because I always do holes next, but do you have any holes?
No, I don't think so.
I think you're right. Do you know why we don't have any holes? What would we be looking for?
We would be looking for the bottom dx. Factors that cancel.
Factors that cancel. Thank you, Artine. That's what we'd be looking for. We don't have any factors that cancel, so no holes. Brenda, how about vertical asymptotes?
X equals 3 and x equals negative 3.
Good. X equals 3. X equals negative 3. I'm going to graph as I go because I think it helps me spot mistakes. If I graph something that doesn't look right, then I probably need to go figure out what happened. So x equals 3 and x equals negative 3. Pretty much anytime you have two vertical asymptotes, you just got to be on heightened awareness here, because weird things happen when there's multiple vertical asymptotes. So we can handle it, we just got to be careful. All right, the ha and the sa, the horizontal the horizontal or slant asymptote. Moises, what do we got going on here? When x gets really big, what does y approach?
Wait, what?
when x gets really big, that's how we figure out if we have a horizontal or a slant asymptote. Which one is this? Do you use the rhyme or do you try to plug in infinity? I need to know how to help you through this one. Or do you have any idea what I'm talking about? Okay. So x going to infinity, that's how we figure out what those end behaviors are. Like when x gets really big, what's happening to my graph? So if I plug in x going to infinity, the top's going to be really big, the bottom's going to be really big, but which is going to be bigger? Why are you saying the bottom? I agree. There's two of them. There's two factors down there. You're going to have infinity times infinity. So even if I have a lot of money and I divide it by an infinite number of people, how much does each person get? Close to zero. Yep. So that's the sort of way to reason your way through it. If you want the rhyme, it's top no, bottom O, equal co. So this one's a bottom O because it's bigger on bottom. Somebody answer Brenda's question. How do we know if there's a slant asymptote? If the top is heavier. Yeah. If the degree is bigger on top. So this one's a bottom O. That's the easiest of the cases because you don't have to do anything. The answer is 0. Y equals 0. Speaking of, let's go ahead and graph that. X-intercepts. Cash, still weird to see your name in the 7th period box, but how do I find x-intercepts?
0 in for y.
0 in for y. I like that. Maybe Mia could help me short circuit this problem a little bit. Mia, what makes a fraction equal to 0? The top being 0 or the bottom being 0? The top being 0. So it doesn't even matter what's in the bottom. All I care about for an x-intercept is what's in the top. So, let's just keep picking on people. So Charlie, what would make the top be 0? What value of x would make that be 0? Good. So -1, 0. And as you get more comfortable with these, some of you will show even less. Like I stopped showing the denominator because I know it doesn't matter. Some of you will stop writing anything down. You'll just know that x-intercept is when the top is 0. So you look at the top and know that that's got to be -1. That's fine. Abby, how about y-intercepts? How do we find a y-intercept?
Put it equal to x. Or put x equal to...
Put x equal to... There we go. Put x equal to 0. So I'll plug in 0 for x. So 2 times 0 plus 2 is 2. Over 3 times -3. That's kind of annoying. But again, these are complicated. It's hard to make everything come out to be a nice integer, so you usually get a fraction somewhere. 0, -2/9. Alright, that's not a lot to go on. Maybe the middle looks like that, but I don't really know yet. Let's find the ends, and then we'll figure out if we need to do more to figure out the middle. When I say the ends, I need something over far enough to the right to be into this region. So what would be a good x value that would put me out there? 4. Or anything bigger than 4, but 4 seems like the best choice. So let's see, 2 times 4 is 8. 8 plus 2 is 10. It's going to be one of those spots where you've got to be able to do all these little math problems quickly and accurately. 4 plus 3 is 7. 4 minus 3 is 1. 10/7. my favorite number, but not terrible. Because what's 10/7 equal to? Just over 1. 1 3/7. 1 and a little bit. And it's nice and tucked in close to both those asymptotes. So I'm pretty sure I know what's going on here. If you want to plug in 5 and 6 and 7, knock yourself out. But 1 point per branch is all that's really needed. And I would say that helps confirm what I think is going on in the middle, right? Because these things usually change directions across the vertical asymptote. So it's going up on this side, it's probably going down on this side. Let's try -4. See if that sort of fits the pattern for what we think is going on. If the middle does look like this, then where do we think the left-hand branch is, above or below? I think below. So let's see what happens if we plug in -4. Let's see, -8 plus 2 is -6. -4 plus 3 is -1. -4 minus 3 is -7. So let's see, 2 negatives make a positive, but 3 negatives make a negative. So -6/7 is below, like you guys said it was. So now I feel pretty good about what the middle looks like. Now, if you're worried, you could plug in -2, or 1, or 2, or all of them, and really get a nice clean graph. But that's probably good. Maybe this is one where you're like, man, this is complicated, there's a lot of stuff. So maybe it would be wise to check 2, just to make sure that we're continuing down over here. Completely optional. I've got all the points I need. But if I'm not sure what's going on, keep plotting points. 4 plus 2 is 6. 2 plus 3 is 5. 2 minus 3 is -1. So -6/5. I guess I thought it would be farther down than that, but at least it still fits the pattern I thought it would be doing. Something like that. Goodness, a lot of information on that problem. And yes, there is one on the test like that, and by that I mean where you'll have to add or subtract fractions to start with. Please, pretty please, get that addition or subtraction right. Otherwise, you're doing a whole lot of work on a wrong problem.